Hi, good afternoon, good evening, everybody. Welcome to this webinar by GAVS on how will AIOps let IT managers sleep peacefully. It's a very interesting topic. I myself are intrigued many a times trying to figure out the answer to this question. Before I let the discussion start with my speakers, there is actually a poll question which we are getting you to respond to. And the poll question is, does AI really replace humans? The answers which we are requesting you to respond to are yes or no, they cannot replace, or no, they can only augment. It would be a 15 to 20-second response time we'll wait for while we are trying to understand, does AI really replace humans? And that's what the participants today will be speaking about and giving their insights on what does AI really mean to us? How does AI really help us? Does it really help us? If so, how? And towards that, we have an elite panel, which we have today talking about it. We are going to have a detailed discussion with both the combination of purists and technologists, and also an operational expert who has actually seen the journey of AI in his own organization. I hope you're all responding to the poll now. I once again repeat, the poll is, does AI really replace humans? Please select one of the three. The first option is yes, yay. Option B is no, they cannot replace. Option C, no, they can only augment. Can I request the webinar organizers now to close the poll? And I'm sure we will have some opinion from the audience, and we will be in a position to take it up while we go. Thankfully, and it's also in line with what we thought, the highest responses come saying that they can only augment, and so true. Few of you felt that it replaces humans. Few of you felt it can never replace humans. Now let's get to speaking to the experts to understand their views and their experience of AI in both their academic and implementation background and also an operational front. With great pleasure, I would like to invite Mr. Sankaranarayan R, Senior General Manager, Information Technology, HDFC Limited, managing infrastructure, security, end user support and compliance within HDFC, and been with HDFC for over 28 years. Has started a stellar career as a software engineer. But more importantly, if you really look at his academic background, he has a BSc in physics, but has done a master's in business administration in administration itself, and is CISA certified. Welcome, Mr. Shankar, to this fantastic webinar.
Yeah, good evening, everyone. Yeah, thank you.
I would like to now introduce you to Professor Nandan. Professor Nandan Sudarsanam is an associate professor at IIT in the Department of Management Studies, and he is a technology advisor to GAVS. He is a core member of the Robert Bosch Center of Data Science and Artificial Intelligence at IIT Madras, has earned his PhD in Engineering Systems Division at MIT, following which he has worked as a quantitative researcher for 5 years at a high-frequency algorithmic trading firm in New York. And I'm sure jump from there to the academics, which he is now pursuing with a lot of passion, is going to be totally different, and we'll hear from him. His research and work experience focuses on experimentation of applications using machine learning, abstraction of data and models. I have been a recipient of some of his sessions, and I'm sure he will bring some very interesting perspective. Welcome, Professor Nandan.
Thank you, Balaji. Happy to be here.
I'm also equally happy to introduce you to my colleague, Chandra. Chandra heads the IP team at GAVS, a very passionate leader, a leader who truly believes in how AI and automation can really play a stellar role in driving operations, has about 25 plus years of rich experience in IT, infrastructure management, design, development, you name it in the infrastructure space. I'm sure he can pick up a topic and talk. He always thinks ahead, and I've seen that personally myself, that he comes up with ideas, acronyms, and scenarios which probably are a little out of the world, wacky to say the least, but that's his strength, and we are very proud to have him as part of the organization. And he has been one of the key players championing the cause of the AIOps initiative within GAVS. welcome Chandra to this fantastic webinar.
My pleasure, Raji, Professor. Thank you.
Let me start, Chandra, with you, because I have had the opportunity of discussing this with many times with you. How do you actually see AI as a critical element in whatever we do? And especially because we keep talking of digital transformation in a very big way. What and how do you see AI playing a role in that space, Chandra?
Thanks, Balaji, for starting with me. So first, let me tell what digital transformation is. Not that the audience do not know about that. That will set the context where AI plays. So digital transformation means adopting new technologies to increase the revenue, increase the profits, and improve, most importantly, the customer satisfaction. It may sometimes require replacing the traditional processes and services with new thoughts and ideas. We have seen that. And it involves a lot of deeper and broader analysis of customer behavior, customer preferences, and following up with customer. We will see in this how an auto manufacturer did that successfully, customer capacity to buy or not, or when to buy, competition. Innovations and advancements in data capture tools, there is plenty today, and the storage devices enable us to have enormous data for analysis. Today, storage is not a problem. Availability of data may be a problem, but we have plenty. Reading all those data and understanding the hidden insights by a human is tedious and time consuming, and it will not be consistent. The consumer's behavior and the preference changes very dynamically. That the real-time analysis is needed for a real digital transformation. And a machine with a human intelligence can only do this kind of real-time analysis, and a human cannot do. So that is where the AI plays a very important role in digital transformation. Going further, predicting a sale or what needs to be done to influence a deal is something that AI can handle better than humans. Again, that is coming from the strength of how the AI can deliver consistently than a human brain. The human brain can't go through all available historical data and mark a prediction and prescription. The deep learning capabilities of AI helps in identifying the patterns of buying or not buying, or what the customer is thinking, factors that influence a buy or again not buy, and then make predictions and recommendations effortlessly. That is most important here. A human cannot do. And let me tell one instance how an automaker has successfully used the AI for sales. So they invested heavily in a centralized CRM data center and started capturing every interaction with their customers and the potential buyers. So this actually allowed them to understand the psyche of the customers and their expectations in every touch point. It keeps changing, and then they were actually keeping track of them. Using the predictive intelligence of AI and the real-time segmentation, the automaker could actually drive more effective marketing techniques. In fact, they actually reached out the people at the time of buying, and actually they could make huge sales. Only with AI, actually, they could make this. Coming to in our area, in IT operations, where we are, predicting the outage and remediating them in advance enables the business to run business critical applications without any interruption, which is very important. That means more business for the organization. AI in IT operations, it's called AIOps, helps organizations in KYA. This is what we call like know your application, like the way know your customers in financial institution where Shankar is there. Know your application is very important, and then understand your applications, like the way you understand your customers, what are his preferences, what he can, what he cannot. And then customers' behavior, then predict the behavior and then remediate an action. There cannot be any meaningful and successful digital transformation without AI. That's my view, Balaji.
And you touched on some very important points, right? Where AI can not just help you in figuring out automation, but can go much beyond that. And when we're talking of AI, Chandra, you and me have spoken many a times about the element of intelligence rather than just the process or the rules which are there. Now, right. Professor, taking a cue on what Chandra spoke with regards to an automaker, and also you coming in with a fantastic background of both academy and industry collaboration. People keep talking a lot about intelligent automation. People are talking nowadays of automation with the mind and with the heart. Now, if you think newer ways of intelligent automation. What are the new techniques people are trying to get to, and what do you see as trends there in intelligent automation, Professor?
Sure. Thank you, Balaji. So I think this becomes very domain specific, this question itself, right? Because like Chandra pointed out, a lot of what we're calling automation right now is merely the fact that digitization has taken over in a huge way, right? Like, so, I mean, if you take something like commerce, it's parallel being e-commerce. If you take something like social interactions, it's now you're onto Facebook, and if you take other industries like the transportation or finance or manufacturing, a lot of things have moved to a more digital space of operation, like healthcare, again, as a great example. And AI lives and thrives on this platform, right? So much of what you're seeing in the form of automation is just AI living on the layer of IT in some sense, right? And with the ability to have like easier storage, withdrawal, better algorithms, better compute, and so on. It's one of those things where we're getting more of something, but that's actually transforming the way we do business. Although it seems like a more seamless and obvious extension, it actually is not. But one of the most interesting things, when you take it, when I take it specific to IT, and when you think of IT even as a horizontal or and something that goes hand in hand with AI, right? The definitional difference that of machine learning itself is where that intelligent automation is happening. Because in the past, before AI, when IT existed, a lot of it was, like you're rightfully saying, writing out explicit rule-based instructions. So code meant everybody was thinking the same thing, which is how do I automate, but that meant writing a rule that a human being would have previously done. One of the 101 definitions of machine learning is to say, I should not be writing rules. I should instead be feeding in data and learning from data, right? And so the rules, so in a sense, you can think of the rules as being learned implicitly, or you don't even need to think of it that way. And that's where the intelligence is coming in, right? And this is for a variety of reasons. I mean, I don't need to sell to this crowd as to why automation is itself a good thing, right? Because obviously we as human beings, we come with a lot of biases, very well documented biases and forms of thinking. So when all you're doing is writing a rule that a human being is ultimately deciding, those biases still translate into what you're doing. Right? But instead, if I teach the computer the ability to learn from the data, then tomorrow I can change the data. Tomorrow I can curate the data the way I want. And so that completely takes out biases. Now, you still need the human being, right? But in a very different way. It turns out human beings are great at making decisions about many things, but they don't know why they made the decision. So when you ask a person to write a rule, you're forcing them to not make a decision, because the first point of automation is they don't make the decision each time. So now you're forcing them to write a rule about why they made the decision. And the truth is they really don't know why they did what they did. Mm-hmm. But however, you still involve the human being and ask them important questions like, hey, what do you think are the factors that go into a decision? Then you can go about writing an algorithm that can learn from data objectively, or even use the human being to tell you which decisions were made at which points. So you take that why, you take the bias, you take all of that out of the picture, and what you have is something that's the next layer of automation, which is not explicit rules, but the direct ability of algorithms to tap into data and sometimes not even spell out the rule for you, but to take the decision in an autonomous fashion.
Oh, interesting, Professor. And as an extension, right, I was a little intrigued by some of the last points which you mentioned. While this audience doesn't need to be told what is automation and how automation really benefits, I think it would be good, with your vast amount of experience in your academic background, just touch briefly, Professor, if you don't mind, as to what techniques of machine learning are today being applicable, or at least introduced to some of the techniques, because people have this myth that machine learning is complex and difficult and unnerving to many people. Just a quick intro of machine learning before I proceed to the other panelists, please.
Of course, of course. So broadly, when you look at it, machine learning is a kind of broken into multiple ways. And one of the most popular one is something called supervised learning. So in supervised learning, what you have is you have this notion of predicting an output given a set of inputs, right? So it might, one example of an output that I'll say in an IT context, for instance, might just be how long will it take to close a ticket, or the likelihood that something will go down. That's an output which is very useful to know. Now, you start by saying, hey, what are some of the things that influence this output? And that's where sometimes a human being comes in and the feature engineering comes in. And there's a lot of data associated with it, right? For one, you have a history of tickets that have been raised that have been closed. You can study the amount of time that has taken, and you can study the factors that determine what took longer, what took lesser, right? So one of the most powerful paradigms that we see is supervised learning, where there is a notion of one explicit output, right? A whole series of inputs, and the job of the AI agent or the algorithm per se is to actually learn the relationship between the inputs and the outputs. It doesn't have to learn it in a way to communicate to a human being, but it has to learn it in a way such that tomorrow, when I give you the inputs, you can predict the output, which is of value to an organization. If as soon as a ticket comes, I'm able to say that, hey, it's going to take this long, right? Or as even before an event happens, if I say there is a 70% chance something is going to go down, right? That means we can respond to it. An organization can respond to it. An organization can prepare for it. Of course, the number of examples in other domains are almost endless. But one of the core principles of supervised learning is this notion of having an explicit outcome variable and a whole bunch of input variables, where it is useful to take these inputs to predict the output.
Right.
And you have some historic data that has helped you develop this knowledge or learn this relationship between the input and output. Sometimes that looks like a fancy math equation. Sometimes it feels like a series of algorithmic instructions. If X is less than this value, if Z is less than that value, then Y must be this. Right. So sometimes it feels algorithmic, sometimes it feels mathematical. Sometimes the math is complex enough that a human being can't make sense out of it. But the algorithm allows you to make predictions for the future, right? There are, of course, multiple other paradigms. Sometimes the goal in another one called unsupervised learning is to not have an explicit output, but to identify patterns within the data itself. So there's no one output that I'm looking at, but as long as I can take, for instance, 50,000 alerts or 1 million alerts that have occurred in my system, are there patterns? Do some things always happen together? Or if one thing happens, do I always know that something will happen later? Now, there is no one thing that is an output here, but just identifying patterns within the data itself can be very powerful, and that's the paradigm of unsupervised learning. Now, in the interest of time, there's another one that I'm very excited about called reinforcement learning. Maybe we can come back to that a little later. I want to make sure there is enough time for everyone to.
No, Professor, it's always intriguing to speak to you. And every time I speak to you, I learn something new. So thank you for at least bringing that myth out with regards to that. Shankar, before I come to you on the same purist point, let me go to Chandra quickly, and then I'll come back to you, Professor Shankar. Chandra, as a purist now as well, as an extension of you working closely with Professor and IIT, how have you seen AI significantly enhance operational efficiencies, provide a lot more power and intelligence to the engineers on the floor and the analysts? And more importantly, how do you see it driving predictability of operations, Chandra, from what you have seen and implemented already?
Thanks, Balaji. Again, thanks, Professor, for that learning and different learnings that are there. And I will take the audience through the journey that I have gone through in the IT operations and where I actually felt the AIOps as really helping the engineers. See, over the years, the IT organizations have spent more time and money implementing many tools. It's quite logical, one for OS, one for network, one for database, and another one for applications, and many. In fact, we have seen organizations running about 15 to 20 tools in their environment. Since we don't know how these systems behave, what we do is we set a very conservative and safe threshold for alerts. Now, what happened? All these tools generate alerts, and the IT engineers are flooded with alerts. So a few years ago, we were not having any alerts. Now we are having plenty of alerts. But actually, if you look at it, the 95% of those alerts do not require any action because we have set a safe threshold without understanding the system. All these alerts are actually not an indication of system performance, but our failure to understand its behavior. That's what it means. The more noise means that we have not understood the system. So the AI, the artificial intelligence, actually helps in understanding the behavior of each such system. And it actually helps us set the right threshold. This is what we call the pattern-based threshold. Understand how the systems and applications behave and accordingly set that. Once you set that, the number of alerts that could turn out to be non-actionable actually goes down. So this is one way of helping the IT managers and engineers. Again, the second one, like me, so many others in this webinar actually have grown up with the systems and experienced one thing, that if you receive an alert from system A, that is actually not caused by the same system, it could be caused by some other system. And that could be caused by some other system. So for every incident or alert that we have, there could be 2 or 3 other systems that could have contributed to this. Now, how do we find these related alerts? So this dynamic relationship of alerts is very, very critical for finding the root cause of an incident. Without this right root cause, we can't put the right corrective action. Without the right corrective action, we cannot guarantee that incident would not reoccur. Actually, AI helps us in finding the real root cause and hence the right corrective action and hence eliminate that incident in future. Again, here a true AI, which Professor talked about, should be capable of correlating the alerts by just looking at the patterns and the frequency at which they are generated and not with any additional data or tool. This is what we call as a pattern-based correlation. Just look at how these alerts keep coming from various systems, look for patterns, frequency, and then actually correlate them. We have seen a very, very successful correlations using that. In fact, we have seen that that kind of correlation is much, much better than the rule-based correlation. The third one is again interesting. Correlating alerts after they occur is fine, and but at the end of the day, it is just reactive. Then we asked our one question. So why do we need to generate alerts and then correlate and then hail victory? So that's not corrective. And AI is supposed to be predictive, not reactive. So why don't we do something that we can prevent the incident from happening at all? So AI actually helps predict the application's behavior in the coming days and alerts and IT engineers and managers in advance so that they could actually take action and prevent that incident. With the continuous learning that AI practices, that is important, the learning that Professor talked and many other learning, it continuously learns and it actually looks at what is the resolution that we are providing for each of them. And it actually learns that. It is what we call the prescriptive measures. And it actually uses that to remediate that. So it not just predicts, it also provides the prescriptive measure, what needs to be done. Then once that is done, then the remediation actually, automation kicks in. That's the one that Professor talked about. Then the last thing, the humans are not born to do the same thing again and again. So human time is very, very precious. Any activity that needs to be repeated deserves to be automated. Or any prescriptive resolutions that have already been done once, executed once, should be automated and not done by the humans. This is done by the automation, and we have intelligent automations, which is intelligent enough to pick the signals from the AI engine and then execute that. The amount of manual work that a human does in IT operations is a measure of penetration of AI. Lesser the human efforts, actually higher the AI adoption. To summarize, Balaji, for your question, the true AIOps platform should discover applications, monitor the discovered applications, analyze the alerts and events from the applications, predict the high impact incidents, prescribe resolution, and automate the resolution. A tool like this will elevate the IT operations to the dependable state and let the IT managers sleep peacefully. I will touch upon this point again. That's what AIOps. That's how AIOps helps the IT managers.
Oh, thank you, Chandra. Thank you. And I think a combination of you and Professor gave some insights about what is AI and how ML helps in AIOps and how AIOps can actually help. Mr. Shankar, sorry for keeping you waiting. You are the most consuming person of all the techniques which Chandra and Professor speak about. So, and it's a privilege and honor to be working in HDFC and be associating with you. How have you seen this level of AIOps, this level of automation, this level of deploying the AIOps solution, which you have taken a leap faith last year? How have you seen it improve efficiencies, bring down costs, improve productivity of operators, but more importantly, align with the theme of today, which is to let you and your engineers sleep peacefully? How do you see all of this achieving some of your goals, Mr. Shankar?
Yeah, thanks, Balaji, and good to hear from Chandra and Professor. I will just take you 2 years back, as Chandra was mentioning. See, typically we all of us had a traditional monitoring tools, right, which used to give a lot of alerts. I would call that as an alert fatigue, because it's thousands and lakhs of alerts comes to the engineer, and in result, there's a risk of missing out critical alerts. That also used to happen because of this flooding of alerts in the system. So we started exploring for a better monitoring tool. Okay, and when we were evaluating many vendors, then at that time I think GAVS also approached us. So we shortlisted GAVS due to its AIOps capability, because at that time it was we were very also wanted to try out whether it really helps what it meant to do. So we deployed this solution around 1.5 years back. Okay, so as rightly pointed out, the first few months we used to get a lot of alerts, because I think the system was learning and a lot of fine tuning was done by our team of engineers, so that it gets matured slowly over the period of time. And initial 4-5 months, I know my engineers, they really had sleepless night, because this used to give a lot of alerts even at midnights for the critical application. We call it P1 incidents. So a lot of calls used to come middle of the night. So, but we had to solve the problem. So all this used to happen in the beginning of the deployment. Now, how it has benefited? Definitely, all the benefits what Chandra mentioned, because it has drastically reduced the number of alerts itself. Because it 95% of the alerts, what we call, it filters low priority alerts and actually gives the genuine alerts to us. So honestly, our engineer or our team need not have to focus on those unwanted alerts which are totally taken away from the normal monitoring tool. That we have seen it happening over the period of time. And over the last 6 months, every quarter we see some reduction in the number of alerts, because it keeps learning and we are able to see that benefit. So overall, our team's efficiency is improving because of this, because of the and we are able to quickly resolve the issues. A lot of issues are getting quickly resolved, and system availability, I think that is one of the key thing I would like to mention, because if it can predict in advance a lot of alerts, like whether it's a memory, CPU, disk, or anything which can cause disruption to the system, if that can come earlier, definitely it is going to improve our system availability overall during the working hours. Fortunately, we have a working hours of daytime 12 hours, but because of the lot of customer portal and online presence, even at night, we need to be all our system needs to work. So this type of monitoring, AIOps monitoring, is helping us to reduce overall downtime. Basically, that has helped us. Definitely, we are seeing that. So ultimately, the user experience improves. So that is overall I would like to summarize. And in the last 6 to 8 months, I would to tell my team itself approached me and told me there is not even a single call at midnight. The last, so really they are able to sleep well at night. They are not being woken up due to this type of system issues, because all the prediction, everything is happening in advance. So they are able to really sleep peacefully.
So you truly are representing the community which says that AIOps implementation which you have done is actually allowing you and your IT managers to sleep peacefully. So thank you for that insight.
Yeah.
So before I go and have my conversation, I would like to introduce another poll question. Can I request all of the people who are attending the webinar to respond to this poll question? How can AI help go beyond automation? The question is, how can AI help go beyond automation? Option A, intelligent automation, learn, predict, and recommend based on context. Option B, reduce human intervention through bots. Option C, cognitive IoT. Can I request the kind participants to please respond to your choice for this question on how can AI help go beyond automation? As they are responding, one thing which caught my attention, Mr. Shankar, is what you said about learning, right? Continuous learning. In earlier days, you had some teething issues and then it was there. So you really felt that the collaborative approach from your team and the team which is actually implementing the AIOps actually benefited in improving the output of the team, correct?
Yes, yes, definitely.
Right.
Definitely, I would say that because it has learned over a past a lot of things we could avoid. Better capacity planning, and a lot of our team could work on those issues and avoid the problems. Yes, definitely, yes. I think the main advantage I said is the number of alerts, because that used to cause a lot of issues earlier.
The alert fatigue went away. Very nice.
Yeah, alert fatigue went away. Yes, that is a key.
Right. So we'll close the poll question and we will find out what the response of the poll is. As expected, learn, predict, and recommend based on context is what the majority of the participants said. And then, of course, followed by reduce human intervention through bots. And lastly, of course, cognitive IoT. So in this context and in this expectation, I'm sure you're also having a similar expectation, Mr. Shankar. What next levels of automation or enhancements in the way operational efficiencies can be reduced are you expecting from an AIOps platform?
Yeah, one is the AIOps gives us more time as the number of incidents is low. So the business runs as usual, because that is we are able to achieve at least the BAU because of this less. And the infra team, our engineers and project manager and seniors, they are able to focus now on the capacity planning, infra provisioning, security, compliance. So they are able to do so that expectation which we had, that at least now they are able to focus on actual work, projects and other things. We would like to improve, maybe in our setup, we would like to improve more correlation between the application and this, so that it can mature further. We would like to do that more, because now currently what we have, we need to still improve on this, so that it studies the pattern of, as Chandra was telling, if it can actually say a system can be down because of not that primary system, it could be some other system causing a problem to this system. So that slightly we have to mature. I think we are already doing that. And some of the more expectation I have is on the storage and the database. Okay, the storage also, if it can learn not only the alerts. See, alerts is when there is a problem. That is, it says the disk is full or it is reaching some threshold. All these are alerts. But can it also predict me the growth, so that it can say my this I will need this much capacity. So it can also, if it can forecast that, it more capacity in 3 months or 6 months to further improve. If it can do that, nothing like it, based on all the learnings, whatever it has done, can it also predict this type of results? That would actually give us, so that we can plan what is the growth over the, even though we may know, but using the tool that can help us. So ultimate objective on the expectation is, yes, we are already on those direction, achieving operational excellence, consistent uptime for all critical system, whatever we do, and enhancing ultimately the customer experience, both internal and external. So these are the expectation with the automation we will be achieving.
Right. Thank you, Mr. Shankar. That's good. Before I go to the next point, next speaker, I would request all the audience to please post your question on the question window of the webinar platform, and we will definitely take up your questions while we are conversing with the speakers. So Chandra, as the recipient of the customer's feedback, what do you think we can do at GAVS? How does GAVS address some of the expectations or requirements which Shankar, as a very keen customer of AIOps, is actually expecting? Your views on that, Chandra?
Sure. But before that, Balaji, I want to say this. I can't actually resist this when Shankar was talking about their IT managers started sleeping peacefully. So this incident actually came to my mind when he spoke about that. So all of us know that famous film, Life of Pi, right? That won 4 Oscars. And there is a lullaby song sung by Bombay Jayashree. I don't know how many of you know. It was also nominated for Oscar, but it could not win. Before the recording, director of the film, Ang Lee, told Bombay Jayashree how he wanted the song or what's the mood of the song. And he said this still reminds me, that the child sleeps not because he was sleepy, but because he feels safe. That's the message given to Bombay Jayashree, and she actually sang that song. That is what actually came to my mind. It's not only for the child, for any human, the peaceful sleep comes when the things around us are stable, reliable, and dependable. And we at GAVS firmly believe that the GAVS AIOps platform, ZIF, provides the comfort to the IT managers they are looking for and let them sleep peacefully. Thanks, Shankar, for reminding me that. Now, coming back to some of the things that Shankar talked about. One thing, what we are trying now is we are actually using our discovery module. We have done the physical discovery. We are doing the logical discovery. What we are actually trying to do is when an incident happens, when a correlation happens, how can we actually provide both the logical and physical together so that we are able to find out where the problem is. See, if you actually look at it, the logical dependency relationship map will tell there is a time delay between an app server and database server. Now, between this app server and database server, there may be a switch. Definitely one switch or maybe 2 switches if it is actually hosted at 2 different data centers. Now, is that switch creating a problem? If the performance is 10% more than the regular one, is that because of the app server or database server or the device that is hidden between them? That actually comes from the physical topology. We're actually trying to get at also along with that so that we have a very clear view. So that is one thing we are trying to. And again, this is first of its kind in the IT world. I know every IT managers would like to have that. The second one is related to that also Shankar spoke about that. When there is a latency between an application, which is not detected by anything. This is where actually I will say that Shankar and HDFC is actually helping us to elevate the IT operations to the next orbit. Now, how can we actually find out the latency when a database server speaks to your storage device? Again, thanks to that continuous work that we do on R&D, we came out with a solution by which we actually start reading the data that gives the latency between any 2 nodes, app server to switch port to the database server, database to storage. Everywhere start reading the latency between them and then fix a threshold, again, the dynamic threshold, and then start alerting that. So this is the second thing that we are planning to work. And third one is we run APM on about 15 of the critical applications in HDFC. And every month we actually make analysis and provide the recommendations. Now we actually want to make the whole thing zero touch in such a way it actually finds out the recommendations. Now that it has learned enough, it will actually provide the resolutions. And if the resolutions is automated, this is where the automation comes in, and we can actually provide that automation. Except maybe for a change in the code, every other resolutions and recommendations can be done automated. These are a few things we are thinking for HDFC, Balaji.
Nice.
Yeah,
With understanding all of that, Professor Nandan, from your experience, AIOps, people are looking at AIOps, but I'm sure AI can be used in a lot more other areas and other industries. Where do you see as the future of AI coming in, especially with some industry solutions?
So let me take that question in a slightly different way, where, in the sense, more than, I'll answer the question more from an industrial perspective. But one of the key, we're seeing multiple different directions. Almost in every niche area, we're seeing advances, right? So when you look at image recognition, we're seeing advances there. When you're looking at natural language processing, we're seeing advances there. But if I say what people are, getting very excited about these days, or at least I am, let me talk about 2 areas that I think are very relevant. One of them is this whole notion of artificial general intelligence. So a lot of AI has been about replacing tasks, right? So you have a task that needs to be done. And the question is, how does AI fit in to replace the task? But that's not at all how human beings are, right? We're not a set of tasks. And any task we learn in one area pays off dividends in another area, right? You learn to memorize something, your overall ability to learn to memorize itself has changed. So one of the things, I mean, and artificial general intelligence is more of a pure AI computer science term between strong and weak AI. But I like the more industry relevant term, which is called general purpose AI.
Mhm.
So in general purpose AI, you say, let me not build algorithms to replace tasks, but can I get a form of intelligence that has some amount of transfer learning? So one area that people try to approach this is through transfer learning. How can I learn something in one task that is useful for another task? There is the area of meta learning, right? So there's a hierarchy of learning itself. But for AI to be at the next level in some sense, right, you need a form of artificial intelligence that is not replacing individual tasks alone. That expertise in one aspect, just like for a human being, will be transferable to another. And this we are seeing as being a very important, very exciting thing as the next wave. If you have to see AI get to that next wave, it can't be siloed in replacing tasks. The other area that I think is very exciting is reinforcement learning. So earlier I was speaking a little bit about supervised and unsupervised learning. And in both those cases, with supervised learning, your outcome is an algorithm that's capable of prediction. With unsupervised learning, the outcome again is a kind of insight about the data, whether it's a clustering or association rule mining, you're still learning something about the data. So you ask yourself, where does all of this end? All of this again winds up ending as a decision-making tool where a human still decides to pull the trigger or not. So I use supervised learning, and what does it tell you? And then it predicts something for you. Based on the prediction, I make a decision.
Right.
Based on the insight that unsupervised learning came, I make a decision. Again, where are we in this automation world? If ultimately it comes to my table in the form of a report, right? Again, we're stuck with that sense of linearity, which happens where you get a prediction and then the prediction goes to a board or individual who then decides to pull the trigger. So one of the paradigms called reinforcement learning deals with this as a problem of control, not just of learning. So the learning is still there, it's implicit, it's under the hood. If I need to control something, I need to know about it. But the end goal in reinforcement learning is to be able to control a system, be it a robot's hand or an IT system, but not just come up with a prediction. I might need to predict things. I might need to learn about things if I need to control it well. But I am valued, or the AI agent is evaluated on the ability to follow a policy, which means in this given context, the AI agent chose to do something. So we're really going into that area of being autonomous.
Right.
It chooses to defragment. It chooses to do complete a log rotation. It chooses to compress all of this and send out an email. So a lot of that kind of behavior that's autonomous really takes your notion of AI to the next level, which supervised and unsupervised learning itself don't do. And I feel like that is really that pushing the edge of automation, because if you're talking about being autonomous, then let the agent control your system rather than just reporting to the human being with a prediction or something, at least for the tasks that we feel comfortable with.
So you have shared with me many a times about how other industries, like even police department is using it, academic institutions are using it. It is so different to see that the academics and industry have come together on such a very key initiative like AI, right? One, I think, shows the need of the collaboration, but more importantly, it shows how each other can benefit from their experience on each other, which I think is a great example of this partnership right now. So.
Yeah, no, I could not agree with you more. In fact, one of the things that helped us initiate the Robert Bosch Center for Data Science and AI was itself that at a place like IIT Madras, you don't necessarily have a data science department, right? But there are so many people doing data science in their silos of like chemical engineering, mechanical engineering, civil engineering. So absolutely, even at the academic front, you're abstracting the problem to a data science problem. And obviously at the industry front also the same thing is happening, which is you can definitely take, I mean, you need to still know the domain and understand the domain, no questions about that. But when you abstract the problem to the math, when you abstract the problem to, there are some number of input variables and I want to use them to predict an output, it stops mattering what the input is and what the output is, right? It just comes down to the algorithm at that point. And which is why I genuinely believe that something like data science completely, I don't even want to say cuts across, I want to say it almost transcends all the notions of verticals and functional domains and so on. The other thing to also keep in mind is the more and more we create complex systems, the more and more we are building things, it's no longer that the simple artifacts are relevant, right? Like so if you take something like mobility, right? Back in the day, the biggest thing must have been to create a wheel, right? Go from square to round, right? Like so you have a notion of simplicity that it's a single thing. But today, if I want to improve mobility in Chennai, which domain should I go ask? Should I ask a mechanical engineer? Is the next silver bullet the economics of it or the environmental impact of it? I mean, we build such complex systems that again, things you need a set of tools to solve them that don't neatly fit into any one discipline. And so things like data science would just cuts across beautifully. That's where the strength is going to be, which is you're going to a higher level of abstraction about the problem statement.
Right. So Chandra, quickly, I know we are about 13 minutes away, and I would like to wrap up and take some questions from the audience as well. We are having some interesting questions coming in. So Chandra, with all the expectations Shankar has set, with all the expectations and thought process of futuristic approaches, which Professor just said, what next in the AIOps platform at GAVS? What else are you looking for? What else are you really looking at creating some disruptive, at the same time, enhance the platform to do some of the things which both Shankar and Professor spoke about within the platform which you are working on?
Sure, Balaji. Just taking off from what the professor talked about. Why do we need to have that AI in an engine that is outside the systems? Can we move the AI to the source itself? Like instead of letting the system generate alerts and then analyzing those alerts and splitting that out, this is noise, this is false positives, this is actionable, non-actionable. Why do we need all those things? Can the AI be moved shift left, if I can call? I think this is a new shift left in this AI world. Can I move the AI to the shift left and keep it in the source itself? And instead of whenever the system breaches the threshold or whenever the system needs some attention, instead of generating alert and asking someone else to do that or asking the automation outside to do that, why can't we build that internally itself so that the systems will never generate an alert? So this is exactly what Professor talked about, reinforcement learning. It continuously learns, be what the system, be what the behavior. It learns and automatically knows what's the right threshold and when to execute. It has what Professor calls the penalty and rewards. Based on that, it makes sure that the actions are taken without compromising the performance and reliability of the application that are running on the system. And this is what we call as the zero alert system. So that is what where you are planning to do next, Balaji. Second one on the same line, once we implement this zero alert system through reinforcement learning, we just want to make sure that it's a purely zero-touch system. So the command center engineer may not be needed to do anything. They will just look at what's happening, and then probably they may take some action for the future. So today they're all working for today, but with this new system, they may be working for tomorrow. These are the two things we are planning to take the AI to the next level, Balaji.
Interesting you said that, Chandra. I just have a question which has come up, and Shankar, I'll come back to you a couple of minutes. How will AIOps actually help to learn the environment, predict the capacity requirement, and to help the organization for their IT budget plan? Chandra, would you want to be able to respond to that in extension to what you just said, the future of AIOps?
Sure. So the AI operations, because of its intelligence and the predictive capability, it actually makes the systems run at the optimized level. So at any point of time, you know what's the total capacity available and what is being used and what is free. And in line with your budget, in line with your plans for the coming year, you can actually know how much you can actually leverage from the existing resources. And it helps you actually go out what you need to plan for the next year. So through the capacity planning that is built in, it helps the IT managers to budget. Because it has the predictive capability, you can also put that, like today for X number of load, this is what it is. Tomorrow when the load increases, what would be? It will actually help you arrive at that, and you can actually use the data for budget planning and future planning.
Understand. Very good. Thank you. And one more question, Chandra, on an operational level. That's why I thought I'll pose it to you. There is a situation of a SCORM tool, which is actually keeping on popping up too many noisy alerts. How do you think AI can really solve that and get to the real alert and help them solve the problem quickly?
Same, that the pattern-based thresholds, that will really help. So let SCORM generate the alerts like the way it, but the dynamic threshold or the pattern-based threshold keeps looking at and know what is the real alert, what is not the real alert, by again understanding the behavior of the systems in which these SCORM are running, and then filter that out and send only those actionable alerts. This is a classic case for pattern-based thresholds.
Right. And the other thing which has been coming out is, how do you actually define intelligence? And Professor, maybe you can jump in. How do you really differentiate between intelligence being brought out of sanitized data or unsanitized data? Because a lot of times the intelligence of AIOps depends on the data, but the basic data may not be sanitized. How do we get past this challenge and still get something useful out of the AI algorithms themselves? Professor, would you want to respond to that?
Yeah, I think that's a very interesting question. But I think we're going down the wrong line if we expect the algorithm itself to be magic around data that is not just unsanitized, but it's noisy, is asymmetric, is problematic, is non-existent. All of these are very real world problems. So the question is, should I work a little bit more on the algorithms front? And my experience, at least, and yes, people work on that front. My experience has been, think of the algorithm itself as a little bit of a black box, right? A lot of the intelligence, I tell students this very frequently. You take any real world data science project, it's less than 20% that's the algorithm. About 80% is in understanding the data, doing the feature engineering. And to me, that is as equally importantly data science, right? To say, okay, here is this data that's there, and then 50% of the data and one of the classes is noisy or non-existent, or I have only labels for one thing and not for the other thing. So I need to understand this as a data scientist and build algorithms with this in mind, rather than expecting a silver bullet algorithm to address many of these problems. In fact, I think that's the fun part of the data science, right? Otherwise, it's from a coding and implementation perspective, right? If you come up with sanitized data, many of the some of the best algorithms have open source code. It's just a question of a single line item that you're calling in Python or R. So the fun part of data science is in understanding the domain, understanding how the data can be problematic, and how can you play with the algorithms so that you address some of these problems. which is why this is still a field. Otherwise, it would have been productized and commoditized much, easily.
The same user professor has actually asked a question where he's saying, do they need to implement any tool for this to cleanse and sanitize the data, or like what you just responded? I don't think so, but I think you can actually have the AI platform itself play a role of intrinsically sanitizing it and figuring out the right patterns, right?
Yeah, so there are lots of off-the-shelf, data cleaning and tools and so on. But again, my only thing is, I think that is why this is still a field and it's not a product. So becoming a data scientist, or taking courses and learning the whole thing, I think that's where the value is. It's going to be always hard to say that we can productize or commoditize the data challenges.
Right.
Challenges in data are always going to exist, and the way you can address them is by having mastery over the algorithm and understanding the domain really well, so you know where the algorithm is going to fail, or you know how you can go change the algorithm in a sensible way, or how you can sample the data in different ways. So there are many techniques. I mean, you can do a simple search and realize that, oh, if the data is imbalanced, right, you have SMOT, which is oversampling or undersampling. So there are lots of off-the-shelf quick approaches to try and correct for problems in data. But that's why this is a whole field, and we teach courses for this. So it's always going to be hard to find one product that takes care of it. I mean, as an advisor, me and Chandra, we spend hours on calls and meetings to try and understand how we can change something for a idiosyncrasy that is there in the data, right?
Right. No, thanks, Professor. I'm conscious that we are 4 minutes away, so I really need one question across to Mr. Shankar. And I'll close it off with Shankar. For the first question to you, Shankar, is, have you seen any quantifiable benefits of what you have implemented in your organization by AIOps platform?
Benefits in terms, I will just maybe this relates to our team. The quantifiable benefit, I will say, maybe I have to repeat that. Our team now definitely are able to focus more on say R&D, capacity planning, compliance, or explore new initiatives. So there is a time for them. Basically, quantifiable benefit is maybe our team has got more time. The same team who were earlier struggling with all the problems and alerts, and that is the real quantifiable benefit we can easily figure out in terms of they have more time. That is a very visible thing. And second is, of course, the capacity planning. That also has overall improved because of this, all these alerts and this, one can easily plan well in advance whether we need to add any more resource or any action to be taken. All this, this is the second one I can think of where it is directly visible when we keep seeing these alerts and a pattern, and we have a monthly review where it is pointed out that these are the maybe device or the infrastructure where we need more attention. So these are all clearly visible, and overall there is an improved service desk. That is our TAT, the resolution time also has improved. Based on this problem management, resolution time. Overall, these are all easily visible vis-a-vis the traditional monitoring system which we used to have. With the AIOps, all these are easily visible to us.
Nice. No, thank you, Shankar. And that was anyway how I wanted to close the webinar as well, that you are definitely alluding a lot of facts which support that one, AIOps is not going to replace humans, it's going to augment humans. And second one is it has actually helped your IT managers and yourself to sleep peacefully. I genuinely thank all the speakers, Mr. Shankar from HDFC, Professor Nandan from IIT Madras, and Chandra from GAVS. Thank you very much. My name is Balaji Uppili. I'm the Chief Customer Success Officer at GAVS. It was a proud moment to have these 3 eminent speakers talk to us today about what's happening today and what's probably going to happen tomorrow, that AIOps is definitely the future. Don't get scared. Take it easy. It helps you. It augments you. It makes you better. And more importantly, your organization needs it. Thank you all for patiently hearing these three speakers. Once again, thanks to Chandra, Shankar, and Professor, and thanks to the audience for a keen participation and to the organizers of this webinar. See you then with another topic very soon. Thank you and bye for now.
Thank you.
Good evening.
Thank you.
Thank you.
Thanks, Balaji, Shankar, Professor.
Thank you, Balaji. Yeah, Chandra. Bye.
Have a nice day.